In lesson 27, we're going to continue on from where we left off in lesson 26, where we start to talk about how graphs can give us equations of functions, thinking about those factors and how they relate to the roots. So first off, the fundamental theorem of algebra in a simplified version states that every polynomial of degree n has exactly n complex roots. Remember, complex numbers contain all of the real and imaginary numbers. So what this means is, for example, down here I have 4 functions. They're all degree 3 because their biggest exponent is 3. So that means that each of them have 3 complex roots. Those complex roots could be real numbers or they could be imaginary numbers, and they might be double roots, and we are actually going to see something called a triple root today too. So first off, I already have my 4 functions typed in my calculator, and here's kind of a nifty trick. You can type in a lot of functions, and if you press enter on their equal signs, you can turn them off. And so I'm just going to graph the first one. So we're going to look at the graph and then describe the roots. So this one, I am in a crazy window from the last problem I did. This one has 1, 2, 3 real roots. Okay, it crosses at 3 specific places. Nothing weird is happening. So this has 3 real roots. Just to draw a little sketch. This is a super rough sketch, right? It's crossing in 1, 2, 3 places. Looking at my next graph, so I'll go back to y equals and turn on the next equal sign. So here we have a double root and we have a single root. So when I'm counting these, we need to have 3 complex roots. This counts as 2. 1, 2, 2 equal roots, 3. So we'll draw this picture. That's a double root, still 3 real roots. One's a double root and one's a single root. And I'm going to add to this one 3 real single roots. So this one has a double root and a single root. They're both real. I should write that in there too. Okay, and that adds up to still 3 roots. So the idea is, even though the picture looks different, even though we could kind of call it 2 roots, the double root counts as 2 roots. So that's really 1, 2, 3 roots. So 1, 2, 3. The next graph. Okay, let's change our window a little bit. It just looks like a straight line now. I'm just going to, without going to my table, try negative 100 to 100 and see what it looks like. Okay, so now we can see, right, we have 1 real root. This part doesn't come down and cross, so it has 2 imaginary roots. So that's 1 real root, 2 imaginary roots, total of 3 complex roots. Kind of like we had imaginary roots with our quadratic equations when we talked about those last unit. So I have 1 real root, and that's a single root, and 2 imaginary roots. The total is still 3, and my picture looks something like this. So lastly, we just have plain old x cubed. And x cubed isn't the only one that has this situation. If I did some other things to it, we could also get this type of root. So here's a graph. If I turn it on. Okay. Do you see how here it flattens out but only goes through once? When graphs flatten out, that means they have a triple root or possibly a 5 times root. I guess we don't really have a word for that. But basically, there's an odd number of roots. It's not a single root. The flattening out is actually called a triple root in this case. Now, just to show you, and I will draw that graph in a second, basically, it's like we have 3 factors that are giving us the same answer. So even if I did something like that, it moves my triple root over here. So there are other graphs than just plain old x cubed, the parent function for cubic graphs, that give me a triple root. So we'll write about this one. This is a triple root. Okay, and the graph looks like this. So comes through, it does pass through on like the double root, but it has a little flattened out spot here that's 3 roots in the same spot. So it says below are the 4 different types of roots you will encounter in this course. Describe what each looks like on a graph. So a single root crosses straight through. The x-axis. A double root we say is tangent to the x-axis, and we have pictures of them up there. You can draw them again if you want to down here. Touches and goes back in the other direction. I'll add that just so we have a little vocabulary definition there. A triple root flattens out and passes through. So it flattens out at the x-axis, it doesn't kind of stay straight through. And lastly, imaginary or complex roots. And usually we just call these imaginary. Technically, they could be complex numbers. These are does not cross the x-axis. This exercise 3 is supposed to be on the next page, so it is going to go with the next page's video.